So hi everyone, my name is Jonathan Brito. I'm a senior product manager here at Databricks. I work primarily on Delta Lake and I actually lead all of our efforts related to Delta Universal Format. As the title of the session suggests, we're going to talk today about a very common scenario that we're seeing today as more and more customers move to an open data lakehouse architecture. And in particular, that means migrating from a proprietary storage format. And what we'll cover today is shown on the right-hand side of this slide. We'll talk through some of the common challenges that you see with proprietary formats. The example we go through really focuses on Snowflake, but a lot of these challenges are really extensible to really any proprietary format your data may currently be stored in. We'll talk a lot about Delta Lake Universal Format, what it is, how it works, and how you can use it to build a unified storage layer for your open data lakehouse. And then lastly, we'll leave you with a reference architecture you can think about as you move to an open data lakehouse away from a proprietary format. So to tell this story, we'll do it through the eyes of a hypothetical company, and we'll talk through their migration story. So let's give this hypothetical company a name. Let's call it Wayne Enterprises. Few comic book nerds in the room, I guess. So Wayne Enterprises wants to be a data and AI company. But along the way, a handful of characters throughout the company have been experiencing a range of challenges. So we'll dive into the eyes of each one of these characters and see what challenges they're facing currently at Wayne Enterprises. So first, we'll look at their chief data officer, aptly named Alfred. So as the scale of their data has grown dramatically, Alfred has been really hit hard with aggressively growing cost. He's been has a lot of pressure to figure out how to get these costs under control, and these costs seem to have grown exponentially as their data volumes have grown as well. The second character is our platform architect, aptly named Bruce. So Bruce wants to maintain a single copy of their data, but however, he's noticed that there's multiple copies of a single table littered throughout their data platform, and this is causing a host of different problems, particularly around data inconsistencies, as seemingly nobody, not users, not the platform itself, know what the single source of truth actually is. And then not to mention, this is actually adding more to their costs, as they have to create additional copies, which is additional compute, as well as additional storage, which is just adding to the ballooning cost of the company and making poor Alfred on the left-hand side pretty upset. So then lastly, we're looking at the eyes of one of the star analysts at Wayne Enterprises, named Lois. So Lois is struggling to navigate different data silos. She's found the perfect tool for her use case, but can't access the data that she needs because that data is siloed away in a different platform. So many of these problems may actually resonate with folks in the audience, and it really begs the question as to how do we get here? How do we get in a situation where you have all these different voices having challenges trying to make the insights from their data? The next few slides will really dive deep into the architecture of Wayne Enterprises, just to try to see if we can diagnose or catch the causes of all these different problems. So first, we start way back in terms of when Wayne Enterprises first moved over to the cloud and thinking through what their architecture looked like back then. For a lot of folks, this was a really simple architecture. And I'll walk through it from left to right. They have a handful of simple data sources, a MySQL database, some system logs, Salesforce, and all that data lands into an S3 bucket. From there, they ingest that data into Snowflake's proprietary format, which is then used to create a bronze, silver, and gold layer table. So for folks who are using the medallion system, this may look very familiar. And then from there, they have really simple operational use cases. Some BI and reporting that's done in Tableau. And they use Snowflake really for the serving layer for those gold layer tables. But architectures aren't static. Like many organizations, Wayne Enterprises had to introduce new tools to handle new use cases. So for instance, you have one team that wanted to tackle some new ML use cases, and they wanted to use Databricks. So as a result, that team built out a separate data science stack, which you're seeing at the bottom end of the page, built in the Lakehouse AI platform. They want to take advantage of some of the specialized ML runtimes we have here at Databricks, as well as the full suite of ML products you're seeing in the far right. Our notebook tools, feature store for feature engineering, model serving, and as well as ML flow. Across the company, a completely separate team of, say, heavy SQL users, for one reason or another, decided they wanted to go with DuckDB for their use case for local data wrangling. And what they did was basically pick up that tool, and you're seeing that at the far right-hand side of this page. One thing that immediately stands out from this slide is that your new architecture, after just a few new tools being introduced, now has completely separate data warehousing stacks and data science stacks. So we want to start to diagnose the problems that are with this architecture and really get to the heart of what's causing the problems that we saw our various characters raise. So first, if you remember, was Alfred. Alfred had this issue in terms of increasingly growing cost, particularly as their data scaled to petabytes in size. What's actually driving this? So the cause is, if you look at, through a lot of examples of talking with customers, we've seen that most Snowflake customers' bills is actually driven through two things: data loading and ETL. For most customers, this can amount to about 75% of their overall Snowflake bill. So the reason you're seeing these exploding costs is because as these data volumes have grown, you're actually doing your ETL on a data warehouse, which is actually optimized more for serving and analytical queries. So as your volumes get really, really big, you see more and more inefficiencies with your ETL pipelines, particularly with things like inefficient auto-scaling and expensive query retries. So that's where all the ballooning cost is coming from that Alfred's seeing on his bill. Next, we want to look at Bruce's problem. So Bruce was frustrated with multiple copies of data. And the answer to that problem, really you can see is on this, in this architecture laid out clearly. So their bronze, silver, and gold layer tables are all created within Snowflake's proprietary format. Because it's a proprietary format, this data is inaccessible to Databricks or really any other engine that you may want to use. So over time, you have more and more users in Databricks needing to copy data out of Snowflake's native format back into S3. As I mentioned before, data duplication is not only expensive, it also creates a whole host of other issues. No longer you have a single source of truth, so you have data inconsistencies, and you have a really complex architecture because you're maintaining additional pipelines for each one of these copies, as well as I said, different stacks for data warehousing and data science. The last problem is related to data silos. So as you saw, Lois, who's our star analyst, really wanted to use the best tool for the workload. And because a lot of the data is locked into Snowflake's proprietary format, if she wants to use DuckDB, she really can't, because most of that data is really outside of her control. So bringing all these problems in mind, we got the group together and we wanted to lay out what our actual architectural goals are for Win Enterprises as we build out our next generation architecture. So first and foremost, starting on the left-hand side, it's getting the best price performance. So what this means is officially scaling our cost as our data volumes grow. And as I mentioned before, this is really looking clearly into our ETL engine and make sure we're picking the most cost-effective engine to do our ETL. Second is storing a single copy of our data that's accessible by any engine that we may want to use. So what this really means is storing our data in an open table format and our own storage bucket in S3. Today, Wayne Enterprises uses Snowflake, DuckDB, and Databricks, but this should be flexible enough such that in the future, if we introduce a new engine, it doesn't cause any additional problems. Third, as with any migration, we want to minimize our disruption to end users. Migrations require significant effort, cost, and introduce a whole bunch of risk. So we not only want to have confidence in our new architecture, we want to make sure that our downstream users aren't disrupted as we migrate to the architecture of our future. And particularly, we want to pay close attention to the BI and reporting workloads because those can be most sensitive to changes. So trying to make sure that we're actually getting comparable query performance in our new architecture. So if we look at this all together, What it really means is that Wayne Enterprises is trying to build an open data lakehouse. These are all the ingredients that you need. So to switch gears, we're going to actually move more into the design phase and taking these goals in mind, see if we can build a new architecture for Wayne Enterprises. The first step in building a lakehouse is often choosing an open table format. And this is where you see a lot of customers stall. So for some customers, on the one hand, they go through extensive benchmarking. They look at all the various formats, try to see which was the most performant for their workload, and then ultimately make a decision. But for a lot more folks, the difficulty is actually just choosing a format that works with all the engines that they're using today. In this case, that being Snowflake, Databricks, and DuckDB. And then for a lot of folks, there's a lot of fear in choosing the wrong format, because then you may get locked into the wrong ecosystem and then have to have another migration sometime in the future. The three most popular open table formats are Apache Iceberg, Linux Foundation Delta Lake, and Apache Hudi. Each one of these formats has a growing community as well as a vibrant connector ecosystem. Any of these three formats can be an improvement over a proprietary format, but the real question becomes, how do I choose one that works with every engine in my architecture? But if you look really closely at these different formats, the question really becomes, do you really actually have to choose? Under the hood, all three formats have a lot of similarities. All three formats store their data in the Parquet file format. But where they diverge is how they store additional metadata. The metadata itself serves a very similar purpose. It serves as a source of truth and handle things like concurrency control. These formats are even similar in terms of the features that they offer. So on the Delta Lake side, we offer a feature called deletion vectors, which if you aren't familiar, this allows you to really optimize your write performance. So instead of having to rewrite your actual Parquet files for every insert or update, you actually insert every update and delete. You actually just write additional metadata to basically point and reference in the future. On the Iceberg side, they have a very similar feature called positional deletes, which works in a very similar way, solving a very similar problem. So ultimately speaking, you have three formats with a lot of similarities with very minor differences, but those minor differences can have a big impact in terms of your actual decision making. So we saw this problem and we created a solution, that being Delta Lake Universal Format. So UniForm takes advantage of these inherent similarities and allows you to write a single copy of data that's accessible by any engine across any of the three ecosystems. Under the hood, the way that UniForm works is it writes additional metadata for either Iceberg or Hudi alongside Delta Lake, while maintaining a single copy of the underlying Parquet files. So for our particular use case, by writing UniForm, Wayne Enterprise can write one copy of their data, leave it in their own storage bucket, and make it accessible to each of the three engines they're using, that being Snowflake, which they can read this table as Iceberg, Databricks, which they can read as Delta, and then lastly, DuckDB, which through their new Delta connector can also read it as Delta as well. So using UniForm is incredibly easy. Once UniForm is actually enabled, it automatically generates the Iceberg and Hudi metadata for you. So there's no manual conversions, it's just one simple, you'll see in a second, it's actually just one table prop you need to set to actually enable this to work. The Parquet files remain the same. There's no duplication of your data. And then lastly, the metadata itself is actually co-located with the data in your bucket. So if you look into S3, you'll see, for instance, a Delta log, but in the case of Iceberg, you also see a metadata folder that you can then use to read as Iceberg. But to build a lakehouse, you can't just stop at the storage layer. You also need a catalog. Catalog provides unified governance across the platform. So regardless of what engine you're using, you're able to ensure you have consistent access policies are being enforced. However, for folks who've already gone through this exploration, choosing a catalog has its own set of challenges. Different vendors have their own proprietary catalogs, which have restrictions oftentimes as to which third-party engines can both read or write from that catalog. This causes even further fragmentation beyond what we're seeing at the storage layer. Because even if your data is stored in a single format that, say, all of your engines necessarily can read, doesn't necessarily mean that each of those engines can talk to your catalog that you're using. So there's a whole host of new problems once you introduce the catalog layer. We also have a solution for that. So as folks saw earlier today, we open source Unity Catalog. And with that, we provided the ability to connect really to any engine you have in your ecosystem. The way that this works is that Unity Catalog provides open interfaces that really any engine your ecosystem can connect to. Talking from left to right, we have our new Unity REST APIs. These provide access to really the gamut of anything that you can potentially secure. So your managed tables, external tables, volumes, functions. We also support the Iceberg REST catalog. This is something that last year at DICE, we actually announced support when we announced UniForm. So Unity Catalog actually has a read-only implementation of the Iceberg REST catalog such that any external client that's compatible, say Spark, Flink, Trino, can read UniForm by connecting to an Iceberg REST catalog interface. Lastly, this has been around for some time, we also have delta sharing. So this is an open protocol that allows you really to securely share data across organizations, regardless of which computing platform you're actually using. So taken together, you can see the fact that you have UniForm and you have Unity Catalog open source, and they're providing an open source solution that allows you to connect to any client in your ecosystem with unified governance, all from a single copy of data. Now, with these two things in mind, UniForm, Unity Catalog, let's see if we can design the details of this architecture, go a layer deeper. So to start, we start with the exact same sources that we had previously. Our MySQL database, the system logs, Salesforce. The real difference here is that in this time, we're actually going to ingest that data and transform it into Delta Lake tables using Databricks. All the transformations are covered by the Databricks Lakehouse using Spark and Photon. Instead of writing our data in a proprietary format, we're actually going to write our bronze, silver, and gold layer tables in Delta Lake. The data is stored in our own custom storage bucket. And for some folks, to make our ETL even easier, you can use tools like Autoloader for ingestion, or you can use Delta Live tables to write really easy pipelines. The machine learning workloads all remain the same. We can still use the full suite of tools that we have in the Databricks AI platform. But the real trick here is that because our data is stored in our own customer bucket in an open format, it remains accessible to all the various engines that we are using. In this case, Snowflake and DuckDB. So by writing UniForm, instead of having two separate stacks, one for data warehousing, one for data science, now we have a single unified layer for our BI, AI, and ML workloads. Now let's see how we did against our original goals. Let's see if we actually can make Alfred, Bruce, and Lois a bit happy. Okay, so our first architecture goal was to efficiently scale our costs as our data grew. So we wanted to reduce our costs because we were seeing a lot of issues, particularly with our data loading and ETL that we were doing in Snowflake. So for a lot of folks, at this juncture, I know if you have your data in Snowflake proprietary format, one easy solution people would think to is, okay, hey, Snowflake has this new Iceberg support. Should I export my data into a Snowflake managed Iceberg table? The real key question you have to ask yourself is, does this actually solve your problem? So looking at data loading, we'd actually looked at some benchmarks, and we wanted to compare ingesting Parquet files into Snowflake, Snowflake managed Iceberg, and compare that to ingesting those same Parquet files into UniForm using Databricks. And what you're seeing is the results of those benchmarks. As you can see, Databricks remains the best at data loading, where it's 6 times faster in this case than Snowflake managed Iceberg. Not only is it faster, it's significantly cheaper. And these benchmarks we saw at 10x, Snowflake was 10x more expensive. We also ran some ETL benchmarks. So this is looking at a collection of things like inserts, updates, deletes, and just really seeing the difference between writing that data to a Snowflake managed Iceberg table and comparing that to Databricks with UniForm. And as you can see, the results are also very favorable for Databricks with UniForm, which are 1.5 times faster. One thing that's important to call out too is for folks who have looked at Snowflake's managed Iceberg support is there currently are still a ton of gaps with that support. In particular, they actually don't support partitioning. So for folks who have actually been basically working on data lakes for a very long time, this is kind of a bread and butter that's been around for years. And it's actually not supported on Snowflake managed Iceberg tables today. So it really makes doing ETL in Snowflake managed Iceberg, I would say, a bit impractical. So you may have a lingering question, which is, okay, I'm writing to Delta, I'm writing to Iceberg. How is this affecting costs? How is this affecting performance? And the real answer to that question is not at all. The beauty of UniForm is that you're only writing additional metadata. You're not writing any additional Parquet files. And metadata itself is really small. So even for very, very large tables, UniForm is able to write a very tiny amount of metadata. So we actually ran some more benchmarks. We wanted to compare performance or a Delta Lake table between having UniForm on, having UniForm off. As you can see on the left-hand side of this page, it's actually very low overhead. In this case, only less than 5%. Okay, let's check the box on our first goal. We got great ETL performance by moving over to Databricks. Second question, interoperating on a single copy of data. How can we do that? So as we saw before, we had this issue around data duplication. So to really get into the weeds on this, we wanted to walk through the user journey of both writing and reading UniForm through the various engines that we're using, just to see how easy it is and make sure that we can actually make everything work for everyone. So on the left-hand side of this page, really covers how you think about the medallion system using UniForm. We actually recommend only enabling UniForm on tables that you plan to share with Iceberg clients. These are often your gold layer tables that you use to serve, say, downstream BI and analytics workloads. On the right-hand side of this page, you're actually seeing the actual code that you would need to write in order to create a UniForm table. So as you can see, it's incredibly easy. All you need to do is when you create your Delta Lake table, you set 2 additional properties to allow you to write the additional Iceberg metadata you need. And then from there, any write to your table will automatically generate Iceberg metadata. Again, there's no manual conversions. It's that one-time setup through the table property you're seeing on the left-hand side of this page. And then from there, you can read in your downstream engines. So let's actually dive into each one of those one by one. We'll start with DuckDB. So in DuckDB, you can read a UniForm table as Delta. And through some of the new connections that we've built with DuckDB, you can use it with Unity Catalog. And this setup actually just took a few minutes to do. It's really just 3 steps. First, in DuckDB, you need to actually do a little bit of setup. You need to load the Delta Lake extension, and then also load UC. From there, you can attach your catalog, which I said in this case is Unity Catalog. You can use a personal access token to authenticate, and then simply through this code, point DuckDB at your UC catalog endpoint. From there, you can read the table as Delta in DuckDB, all through UC. You see on the left-hand side is actually a screenshot from the DuckDB CLI in which you're actually listing all your tables in Unity Catalog. So I thought it was a really cool experience. Moving right along, handling the Snowflake side of the house here. So in Snowflake, you can read a UniForm table as Iceberg using what Snowflake calls a catalog integration. So catalog integration allows you to connect to an external catalog or to object storage. As of right now, the only supported way to read UniForm in Snowflake is via object storage. To read via object storage, you need to first get the metadata file location from Databricks. You can do this by running the command you're seeing on the upper right-hand side of the slide, basically a describe extended that gives you the pointer to the latest Iceberg metadata snapshot. From there, you then have to move over to Snowflake and then basically point Snowflake at that metadata path. For folks who know more about Iceberg, who have actually tried to do this journey before, you're probably asking yourself, okay, wait, I know the metadata file path changes every time I make a write or any sort of change to my Snowflake table. This could be really difficult to handle. So a lot of times we see customers write custom code in order to make sure they can actually refresh this metadata on some sort of a programmatic basis so they can enable the read you're seeing in Snowflake. The good thing is that UniCatalog already has a solution for this problem. It can make this a lot more seamless. So as I mentioned previously, in UniCatalog, we actually expose our UniForm tables to the Iceberg REST Catalog API endpoint. And what's important about the Iceberg REST Catalog, for folks who aren't familiar, is that this is a really cool part of the Iceberg spec that allows you to basically abstract away the catalog backend. Because Iceberg itself requires you to have a catalog, and there's a variety of Iceberg catalogs you can use. Basically, by using the Iceberg REST Catalog, you can say, hey, regardless of what catalog backend you're using, we're gonna expose these tables through a common set of open APIs, such that any Iceberg reader can talk to the same interface. So as I mentioned, UniCatalog already supports this today. This is something that Snowflake could connect to. And what's exciting is that with last week with the Polaris announcement with Snowflake, it appears that Snowflake is actually standardizing on the Iceberg REST Catalog through Polaris. So in theory, if Snowflake can read from a self-hosted Polaris catalog, it should be able to read from the UniCatalog Iceberg REST Catalog interface, providing a really seamless experience. So we'll have to see. We got some time, I think it's 90 days before they're open sourcing everything, so we can see if we can tick in time and make everything work. Okay, so our last goal was to minimize disruption to downstream users. In particular, we're looking at those BI and analytics workloads. And we wanted to make sure that we continue to maintain our SLAs to those users, in particular lowest, like you're seeing on the right-hand side of this page. So we ran some benchmarks really just to understand what the read performance of UniForm is in Snowflake. This is all out of box. So we compared was a Snowflake managed Iceberg table to UniForm written by Databricks and read that in Snowflake. And as you can see, for an out-of-box benchmark, the results are really comparable. So we're really excited about this ultimately because for Snowflake managed Iceberg, they've done a lot of work to make these as comparable with their Snowflake native tables. So for our downstream users, by moving their ETL over to Databricks, we can still create a gold layer table with UniForm enabled that will still get great performance. So ultimately speaking, your BI and analytics workloads won't be disrupted by making this sort of a move. So taken all together, we've checked every box. We first got fast and cost-effective ETL, so making Alfred, our CDO, happy. We're interoperating across platforms from a single copy of data. So making our platform architect, Bruce, really excited. And then lastly, we're minimizing disruption to our downstream users because we're getting excellent query performance all through writing a uniform table for our gold layer tables. So in this example, we reviewed a really simple example that just had 3 engines, that being Snowflake, Databricks, and DuckDB. But what's really important here is that UniForm is really extensible to any engine that you may choose to use today or in the future. It allows you to take advantage of Delta Lake's rich connector ecosystem, which spans a whole host of ecosystems, Python, Rust, Java, as well as various platforms. It allows you to connect to the Iceberg ecosystem if you need to access tools like Snowflake. And then lastly, the Hudi ecosystem, which very recently with Delta 3.2, we added support for Hudi. This is actually a contribution from the folks over at Xtable who are part of the Hudi community. So with universal compatibility, you can extend this architecture that we just discussed in this more toy example to a more broader real-time use case. So in this case, you can write once, use Databricks for your ETL, have a single copy of your data, and then enable UniForm such that you can have access to the Delta, Iceberg, and Hudi ecosystems. So you can use DB-SQL, you can use Snowflake, you can use all the various Iceberg readers, as well as tools like BigQuery, which BigQuery actually very recently announced support for Delta Lake, native Delta Lake support, as well as the various open source engines. So really you have access to any tool you may use today or in the future, all from one copy of your data. So you can really have that flexibility and security that you'd like. But we're not the only ones who are thinking about the future of interoperability. A really good project that we've been working actually really closely with and collaborating with is called Apache Xtable. So for folks who aren't familiar, this is a new Apache project that actually launched back in December, and they already have amassed an impressive list of contributors, mentors, users, kind of a who's who. Microsoft, Google, OneHouse, Databricks, even Snowflake, as well as a variety of bigger customers. So to use Xtable, it's actually really simple. Ultimately speaking, it provides omnidirectional conversions in a very similar way to Delta Lake UniForm. All you need to do is choose a source and a destination format, and these can be any. This can be Delta, Iceberg, or Hudi in any different direction. And then from there, Xtable forms a very lightweight conversion, very similar to UniForm. So the way that you would actually do this is you'd actually configure a YAML file that has the source and target formats, and then from there you can specify the location to the actual table itself. And then when you need to actually execute the conversion, you can run a jar command to do that. One of the nice things about Xtable is that it's incredibly portable. It's a portable runtime you can really deploy in a bunch of different ways. So I've seen folks use Xtable where they basically run it alongside their Spark writer. So with every commit, you're generating the metadata, very similar to how UniForm works. Or you can schedule Xtable to run asynchronously. So on some sort of a timed cadence, you can run a job that you can orchestrate through Airflow. Or you can eventually use something like a Lambda function if you want to invoke Xtable on demand. So it's a very flexible, very cool tool. We're actually, I said, partnering with these guys quite a bit, and they're actually the ones who provided the support for Hudi and UniForm. So with UniForm, we actually launched a public preview almost exactly a year ago here at DICE to a lot of excitement, and we've been pushing through with the public preview. As a PM working on Delta Lake UniForm, it's really exciting to see just how much usage we've gotten. We actually have seen 4 exabytes of data written to UniForm tables, and this is just during a public preview. What's also important too is that UniForm really has been battle tested by hundreds of customers. We've had customers test UniForm with all the variety of Iceberg readers, including Snowflake, Redshift, really anything you can potentially use. And we've really worked out any potential compatibility concerns. So from there, a lot of these customers are actually moving to using this in production. As you can see on the right-hand side of this page is a really happy customer, M-Science, who's been using UniForm. And they're really seeing some of the benefits we talked to already around reducing data duplication, reducing cost, and actually accelerating their time to value. And now, as of this week, UniForm is actually available in GA. So please check out the blog post that went up last week. It talks about a lot of this stuff and also provides how-tos on how to integrate UniForm with various engines. So there's a handful of blog posts that I could walk you through how to make particularly the object storage connection a lot more programmatic. And I said we'll continue to evolve UniForm as the market evolves and we provide additional support. I wanted to end by just bringing things all together and talking about, I think, the vision we have at Databricks around interoperability, and really the 2 big pillars that I think you probably heard a lot about throughout the course of this summit. So first, Delta Lake UniForm, which really allows you to access data in any format, whether it be Delta, whether it be Iceberg, whether it be Hudi. And then from there, you have Unity Catalog OSS, which allows you to really govern and manage really any asset, not just your data, but as well as other objects. So volumes, functions, ML models, you really name it, you can really use it with Unity Catalog OSS. And then I mentioned previously, all oriented around universal open standards. So you have the Unity Catalog REST API, you have the Iceberg REST Catalog API, and then Delta sharing, which allows you to connect to really any client you may potentially use in your ecosystem. So across the major cloud providers, data and AI platforms, and any other compute engine. So really what we see here with Databricks is allowing you to interoperate and provide you a lot of flexibility in the architecture you build, using things like UniForm, using things like Unity Catalog. All right, thank you.